Hi everyone, this is Dr. Webster, and this video is about conducting and interpreting an independent samples t-test in SPSS. Apologize if you hear my bird in the background, Duchess. She is just being a little noisy right now. But yeah, let's get started. So I am going to conduct the independent sample t-test on the gender stats anxiety example that we did in class. So whether men or women report more anxiety about taking this stats course. So we're going to go to analyze, and then we're going to go to compare means and go to independent sample t-test. You should get this window prompt that comes up here. You can always expand this if we want to. And so you have a test variable box and then a grouping variable box. The test variable box is where you're going to put your DV, grouping variable, IV. So it doesn't matter where you start, but I see gender first, so I'm going to bring that over to the grouping variable here because that's our independent variable. We're seeing whether stats anxiety varies depending on gender. But one thing I need to check out is how gender is coded, because that's going to be really, really important here. So if I go to gender, and look how this is coded. So 0 female, 1 male. That's going to be really important because we have to enter the dummy codes for the groups that we want to compare. So I'm going to bring gender over here. And then when you click on define groups, this is where you get another prompt that comes up, another window. And this is where you're going to enter the dummy codes for the groups that you want to compare. So it could be 0, 1, could be 1, 2. If you have multiple groups with multiple dummy codes, so if you had like a list of race and racial identities, you're going to have 5, 6 racial identity responses. If you only want to compare 2 of those, you just have to see how those identities are coded, and then you can just put the numbers for each of those identities in here. But of course, we're doing an independent sample t-test because we have 2 independent groups, same outcome, right? So we have our dummy codes, 0 female, 1 male. We're going to click continue. And then we're going to bring our DV over to the test variable box. Sometimes that happens. A cord gets loose or something. It's fine. All right, so stats anxiety, number 1. We're going to bring that over to the test variable box. And then you just want to make sure estimate effect sizes, that box is checked. And then you want to paste. Boom. And then we want to highlight, excuse me, and then run. And then we should get our output. And this is the exact output that we saw in class. So we can go through here. When we see in the group statistics box, we have the little n's. The big N here should be a little n, technically. So we have 143 self-identified women, and then 55 self-identified men. And we see the mean for women, 4.62, men, 4.53. This looks like quite a small difference, and if we check out the mean difference over here, it is only 0.1, so it seems pretty small, especially given our response scale of 1 to 7, I believe. So don't know if this 0.1 is far enough away, bigger enough from 0, large enough from 0 to indicate a true and real difference. And so if we take a look, oh my gosh, I messed up, oh my god. Well, before we take a look at our t-statistics, it's okay if we take a look at our means here, that's fine. It looks like a small difference, don't know if it's going to be a significant difference, but the first thing that we want to check out is Levine's test, equality of variances. You want to make sure that Levine's test here is non-significant. That means the standard deviations for each of the groups are non-significantly different. We want equality of the standard deviations. We want these standard deviations to be non-significantly different. And so if Levine's test is non-significant, then we can check that box assume equal variances and move on. And so the p-value for Levine's test is 0.14, much bigger than 0.05. And technically this would be non-significant. So these standard deviations are non-significantly different, and that's what we want. So that means that we can just move on, right, and look at this top row where it says equal variances assumed. And so we have then our degrees of freedom, 196. We have our t-value of 0.41, and then we have our two-sided p-value, right? So SPSS, using the t-value and degrees of freedom, finds the p-value, the associated p-value, and we see the p-value here, 0.682, right? And so technically this would be a non-significant difference, just as we talked about in class, because 0.68 way bigger than 0.05, right? Significant p-values are less than or equal to 0.05. So we have a non-significant difference. So this mean difference of 0.10, round into 2 decimal places, right? This mean difference is not far enough away from 0 to suggest a true and real difference, right? The only other thing I would point out here is that we calculated the t-value. Remember that calculating t-value is always difference over error, observed difference over error. And so to get that t-value, we took the mean difference, 0.1, and then divided by the error term right next to it, 0.23, and that should give you the t-value. So that's one more thing that I will point out here before we go to Cohen's d. Right, so we'll still report Cohen's d and interpret Cohen's d, and when you have a non-significant difference, Cohen's d should be very small or small. And so if we look at the point estimate here, we see that Cohen's d is 0.07 right here, right, which would be very small according to Cohen's guidelines. And we got that 0.07 by taking the mean difference, 0.1, dividing it by the standardizer here, 1.46, and remember the standardizer here. This is the pooled standard deviation, which means that we're calculating an average standard deviation, a weighted average standard deviation. So when SPSS calculates S pooled here, it's going to weight these standard deviations by the n's, the little n's for each group. And as we can see, that there are a lot more women in this sample than men. So the pooled standard deviation should be closer to women than men, because women's standard deviation is going to be weighted more. There are more women. And we see that 1.46, right? It's the pooled standard deviation is closer to women's than men's here, right? Because women have more weight here. But ultimately, we have a non-significant difference. We are not confident to say that the difference here of 0.1 is far enough away from 0 to indicate a true and real difference. So when it comes to our conclusion, right, there is no difference between men and women and their levels of anxiety about taking this statistics course, right? Gender does not ultimately tell us anything. According to this analysis, gender doesn't tell us anything about people's level of anxiety about taking this course, right? By knowing whether you self-identify as female or male, that doesn't tell us anything about your level of stats anxiety. So ultimately, this predictor, our independent variable, gender here, is not meaningful. It is meaningless because it's not a good predictor. It's not telling us anything. Doesn't explain any of the differences or variability in people's level of stats anxiety. So that is the independent sample t-test overview of conducting and interpreting an independent sample t-test.